Hi students, welcome to my YouTube channel SADHIK Physics. So where we are learning the physics very easily. So recently we started kinetic theory of gases. No? In that I did already kinetic theory of gases of 2 videos no? Of theory related and numericals. No? Therefore part 1. So the time was very lengthy. No? Therefore we have selected large number of questions. No? Then we are doing as a part 2. Therefore so here KTG numericals part 2. If you did not watch, please go through the compulsory theory videos, no? Then come back to the part 2 video, no? So that you can understand very clearly. Now let us continue. Therefore our video. So from the different questions, no? We already did nearly 20-30 questions, no? We discussed in the previous video, no? Now we will go for one more question here, no? Let us see here, no? Right. So here a gas that occupies 2 moles occupies of volume of 500 ml at 300 Kelvin and pressure is given. Compressibility factor, no? He is asking what is compressibility factor. Factor. So this is given as pressure into volume, real volume divided by nRT. So this it will be the compressibility factor. Clear? So now therefore here pressure is how much? No, it is given as 50 atmospheric pressure, 50 into 10 to the power of 1.01 into 10 to the power of 5. 1.01 into 10 to the power of 5 into volume is how much? No, 500 ml, 500 into, therefore meter cube we want to write it, no? So therefore you know that 1 liter, so it will be equal to 10 to the power of minus 3 meter cube. So 1 liter is equals to, therefore 1000 ml. So 1 ml it will be equal to 10 to the power of minus 6 meter cube. Clear? So therefore here it is ml, therefore 10 to the power of minus 6 divided by number of moles are how many? 2 into R value is 8.3, temperature is how much now? 300 kelvins now. Clear? So here you can this is 0, this is 6, no? This 0, 5, 10 to the power of minus 6 get cancelled out, no? 3 zeros and 2 zeros and 2 zeros can cancel. 1.01 into 10 it is 5 divided by 2 into 3 into 8.3. You can solve this one, no? You can get your answer. So we will see calculations, no? So 1.01 into 5, 5.05. 6 into 8.3, 49.8. That means 5.05 divided by 49.8, nearly 0.1 value you got it now. Sorry, here no. Therefore 5 5s are again 5, it is also is there. Here again 5 multiply with this, no, 0.5, you will get your calculations now. Clear? So 0.5 will be your compressibility factor now. Clear? So here small this 5 I missed it. Clear? Now we will go for remember this is one new things, no, which I did not discuss in the theory also. This is your compressibility. So it will tells that therefore about the real gas and ideal gas difference. No? Clear? So remember, now we will go for next question. No? Right. So this is one of your JEE main question, no? Clear? So is asked if the collision frequency of an hydrogen molecule in a closed chamber, collision frequency. So collision frequency, this is your mean free path, no? Therefore path is equals to, therefore you know that the speed is equals to distance by time, or speed is equals to distance into frequency. Therefore distance is nothing but a velocity by frequency. Clear? Understood, no? Therefore here now, right? So collision frequency, so therefore he is directly proportional to the not only this velocity, okay, no, another thing is not given. So it is directly proportional to the velocity, therefore and inversely proportional to the mean free path. So here collision frequency is directly proportional to the velocity, but velocity is directly proportional to like RMS speed, no, the square root of the temperature, no, right? So here collision frequency F2 by F1, it will be equal to root of T2 by T1. So root of T2 is nothing but 127 degrees centigrade, means nearly 400 Kelvin by, so 27 degrees centigrade is nothing but 300. So these zeros, no, therefore 2 by root 3. So F2 can be written as, so 2 by root 3 into F1. F1 is given as Z, therefore 2 by root 3 into Z will be your answer now. So this it will be your answer. So here most of the students know they will get trapped, no, only at this point what is the collision frequency. So they will not get any idea, no. So if you solve this type of problems, no, you will get the clarity. Clear? So this is your mean free path, velocity by velocity by 2 by root 3. Velocity is equals to distance by time. So distance into frequency. So therefore here distance is equals to velocity by frequency. Correct? Correct? Clear? So here this concept. Clear? Now we'll go for another question. Right. A vessel is filled with ideal gas at a pressure of 20 atmospheric pressure, no, and at the temperature of 27 degrees centigrade, and half of the mass of the gas is removed from the vessel. Okay. So then the temperature of the remaining gas is increased to 87 degrees centigrade, and at this temperature the pressure of the gas, right? So I told you already, therefore half of the mass of the gas, it is changed. So here you know that PV is equals to, therefore nRT. So PV is equals to N is nothing but mass of the gas by gram molecular weight into RT. Clear? So what is changing now first of all? So right. So here there is a vessel is there, no? This is one vessel. Clear? This one vessel having the volume is V. So filled with an ideal gas, what is the pressure now? Initial pressure is nothing but 20 atm. And the temperature is how much now? Initial temperature is nothing but 27, means 300 Kelvin. Clear? Initial temperature. Now therefore certain amount of mass of the gas is removed, no? So initial mass is m, then it is m by 2 was removed. Therefore remaining mass is nothing but m by 2. Clear? So now the temperature, now what has happened now? Temperature is T2 is increased to 87 degrees centigrade. 87 degrees centigrade means plus 273. How much now? This is 0. So 1, therefore 16, 1, therefore 360 Kelvin now. Clear? So you need to calculate the pressure P2. In this one now, the volume mass remains same. Clear? So what is changing now? What we have to calculate now? Pressure we have to calculate it now. Volume is not changing. Gram molecular weight not changing. This is not changing. So therefore here P by, therefore here MT, this it will be equal to constant. Clear? Why? So pressure we are changing, no, volume is not changing, gram molecular weight is not changing, R is not changing, m t, this it get cancelled. So therefore P1 by m1 into T1 is equals to P2 by m2 into T2. Clear? So therefore here what you can write it now, initial pressure was how much, no, this is here initial and final, no, we'll take it, no, initial is nothing but 20 divided by initial mass is m into temperature is how much, no, 300, so is equals to P2, so then remaining mass is m by 2 into therefore 360. Clear? So this is also m get cancelled out, no, therefore here, so this is should be 180, so P2 will be equal to, therefore these two get cancelled now, therefore it is 1 by 15, no, so 180 by therefore 15. So you can write down 360, 3 5s 5, 12. Therefore, so new atmosphere, new pressure is nothing but 12 atm. Clear? Understood, no? So therefore, in this way you need to able to solve these type of problems. Clear? Now we'll go for another question, no? Right. A flask is filled with a 13 grams of ideal gas at 27 degrees centigrade. Temperature is raised to 52 degrees centigrade. The mass of the gas that has to be released to maintain the same pressure. Okay. So mass of the gas that has to be released. Okay. What is given now? Suppose, now let us see, we'll analysis this one now. Now this is one vessel containing, no. Now here initially, therefore there is a mass of the gas is how much, no, 13 grams is there now. So having volume is V. Clear? So now the temperature of this one is how much, no, temperature is nothing but 27 degrees centigrade means 300 Kelvin. Clear? Now the new temperature it is nothing but T2 52 degrees centigrade, no, 52 plus 273, how much now, this is 5, so this is 12 1, therefore 325 Kelvin. Clear? So initially what was the pressure, no, finally also that much amount of pressure it will be same. Clear? So therefore final mass is nothing but m, so how much amount of mass is going to remain, we want to calculate it now, then finally we can find it now. So how much amount of gas is to be removed, this m dash is nothing but capital M minus small m. So m we know it, no, m we don't know, therefore to calculate m dash. Clear? So we'll calculate it, no, PV is equals to m by gram molecular weight into RT. Clear? So here what is changing now, pressure to be not changed, volume also not changed onto this one, no, therefore only temperature is this one, no, m and T, so mt should be equal to constant. Clear? So volume also not changing, no, pressure is also not changing now. Clear? So therefore here m1 T1 is equals to m2 into T2. So m1 is nothing but initially 13 grams. So next one is T1 is nothing but 300. So it will be equal to m2, this m2 is nothing but a final mass, how much it is remained, into 325. Clear? So this is small m, it can be written as 13 into 300 divided by 325. We'll see it now. So now 13 into 300 equal to divided by 325. So therefore here this it you are going to get it as 12 grams. Clear? That means, so to raise this temperature 12 grams is remaining in this one now. How much amount of gas is left out onto this one now? So already 13 grams was there, finally 12 grams is there, 1 gram of the gas, no, that has to be released. Clear? In this way, you need to see the different concept. Clear? Now let us go for one more question now. Right. Now, the density of the gas at NTP is, okay. So, density of the gas rho 1 is given as 1.3 kg per meter cube. So, at NTP, this is at normal temperature pressure. Clear? So, now what will be the density at a temperature 15 degrees centigrade and the pressure is nothing but so 84 centimeters of Hg. This I can rewrite it at 15 degrees means 15 plus 273. How much now? This is 8. This also 8. 288 Kelvin now. Clear? This temperature is nothing but 0 degree centigrade now. 273 Kelvin. Pressure is nothing but atmospheric pressure 76 centimeters of Hg. Why? Because this is given in terms of Hg now. So, first of all, you should write down the density formula now. So, you know that PV is equals to mass by gram molecular weight into RT. So, mass by volume is nothing but a density. So, this taken here no, that is nothing but a pressure by density. Here you can take it here no, this one no, then volume can take it, or this volume you can take it, mass by volume is this one no. So, it is nothing but a RT by gram molecular weight. So, what is changing now? Okay. So, pressure we are changing now, temperature also we are changing now. So, therefore, here you can write down density is equals to, this I can take it now, pressure into gram molecular weight by R into T. So, therefore, density is directly proportional to the pressure by this temperature now. Clear? Right? So, therefore, here what you can write in now, density is directly proportional to pressure by temperature now. Clear? This it will be equal to constant. So, what we can write it now? We can rewrite it as, okay. So, therefore, oh sorry here no. So, no, this is not constant no. Therefore, here we can rewrite it as one more formula, density by pressure into temperature, it will be constant. Yes or no? Pressure by density into temperature. Okay. So, density by pressure. So, we can rewrite it as density rho 2 into T2 by pressure P2, it will be equal to density rho 1 into T1 by P1. Clear? So, then we want to calculate it now. Density rho 2 we want to calculate it now. Temperature of this one now T2. T2 is how much now? 288 by pressure is how much now? 84 centimeters of Hg is equals to, density is given as 1.3 gram per kg per meter cube no. Temperature T1 is nothing but 273 by 76 centimeters of Hg cancel now. Density rho 2, therefore 1.3 into 273 into 84 divided by 288 into 76. Simplify, you can get your answer now. Clear? So, here 1.3 into 273 into 84. So, therefore, here 29811.6 divided by 288 because divided by 76. So, therefore, totally I will get it no 1.36 kg per meter cube. This is your density. Let us see one more question. Right? A vessel of volume, therefore he gave the volume here no. What is the volume now? V1 or V is equals to V is equals to 2 into 10 to the power of minus 3 meter cube contains how many moles now? 0.1 mole of hydrogen and 2 moles of, okay, this is one, this is your hydrogen no. So and 0.2 moles of helium if the temperature of the mixture is 300 Kelvin no, then the pressure of the mixture no. Okay, both are mixed in the same volume no, therefore PV is equals to N1 plus N2 into therefore RT. So we want to calculate here no, pressure into volume is given 2 into 10 to the power of minus 3. So how many moles are there? 0.1, 0.2, therefore 0.3 into 8.3 into temperature is how much now? 300. Clear? So pressure it will be equal to, so 0.3 into 8.3 into 300 divided by 2 into 10 to the power of minus 3. Okay. So simplify, so you can get your answer no. So here this taken top no, therefore here this one no, 10 to the power of 5. So 0.3 into 8.3 into 3 divided by 2 into 10 to the power of 5. Clear? So let us see, 0.3 into 8.3 into 3 divided by 2. So therefore here you can write down 3.75 into 10 to the power of 5 Pascal. This is your pressure because of due to this mixture. No? Clear? Now we will go for another question. No? Right. This is slightly interesting question. No? So you need to understand very clearly. Here are 2 moles of helium. Okay, helium means monoatomic. No, number of moles are how many? 2. How many moles are there? 2 moles is contained in a container of at STP. So at STP, therefore it is given at STP. So the heat energy needed to double the pressure now. Therefore here what you require now, heat energy needed. Therefore delta Q, keeping the constant volume, therefore NCV into delta T, delta theta. Number of moles we know it now 2. So here monoatomic CV, what is the CV formula no? Right? So therefore R by gamma minus 1. So gamma value is nothing but a for monoatomic no, we already studied no. So 1 plus 2 by 3, monoatomic means 5 by 3. So 5 by 3 minus 1 means therefore 3R by 2. So okay, 5 by 3 minus 1 means 2 by 3, it cancel, it is inverted no, 3R by 2. So it is into 3R by 2 into delta theta. Delta theta don't know, we don't know the temperature, final temperature minus initial temperature. Initial temperature at STP no, therefore initial temperature is 273 degrees, Kelvin no. Clear? We don't know, but what is given now? Pressure will become like a, so this is your final pressure will become like a 2 times of your initial pressure. Initial pressure is nothing but a atmospheric pressure, suppose we will take it as P. So for this no, temperature we know it no, constant volume, volume is constant, therefore pressure is directly proportional to the temperature no, therefore here P1 by T1 is equals to, therefore here P2 by T2. Clear? So P1 is nothing but initial pressure is P by temperature is nothing but a 273 is equals to, so P2 it will become like a double time of this one no, by T2. There that implies, so therefore T2 will be equal to 2 into 273 Kelvin. Clear? How much it is raised in temperature now? Therefore these two get cancelled now. 3R. This is 2 into 273 minus 273. Therefore 273. So will be a difference in the temperature now. Clear? So therefore R value is also heat capacity right. Heat capacity is given no. Okay. So we know it now, we can rewrite it, we can solve this one no. How? So here 3 into 273 into 8.3. So therefore here 6797 joules. This is your answer. Clear? Clear? So now we'll go for another concept, another question. So here number of moles of the gas, therefore N is equals to 1 mole. Yes or no? So here oxygen, so therefore here O2, it is a diatomic molecule, and at constant pressure from this one, therefore at the same pressure. Therefore is asking amount of heat, therefore delta Q at constant pressure NCP into delta theta. Clear? So we don't know the temperature, right? So Cp we can calculate it, Cp is equals to gamma into R by gamma minus 1. So gamma value you can write it as like a, so here 1 plus 2 by, therefore 7 by 5. So what you can write it now, 7 by 5 into R by, therefore 7 by 5, 2 by 5. So therefore 7R by 2 will be your Cp value. Therefore you can write down how many moles now, 1 mole into 7R by 2 into delta theta. We want to calculate delta theta now. So here to double its volume now. So initial temperature was how much now? Initial temperature is 273. So therefore Kelvin now. Initial pressure is nothing, pressure is constant, initial volume is V1. So therefore here initial volume is nothing but a V. So here final volume is nothing but we want to double the volume, So what will be the final temperature now? Clear? So we know that, so V is directly proportional to the temperature, So therefore here V2 by V1 is equals to T2 by T1. So V2 is nothing but a 2V by V is equals to T2 by T. So therefore here T2 will become like a 2T. Therefore 2 into 273 Kelvin. But here difference in the temperature is how much now? 2 into 273 minus 273 means 273. Therefore 1 into 7R by 2 into 273. So this it will be your answer now. Now we will write it, we will see it. So here 7 into 273 into 8.3 is equals to, it is divided by 2. So therefore 7930 joules. R is asking in terms of calories, So 1 calorie is equals to 4.2 joules, or 4.18, Therefore this answer 4.2. So therefore 1888 calories or 0.25 calories. This it will be your answer. Clear? So in this way you can solve the problems. Now we will go for one more question. Right. These are NCERT questions, very very important. Which of the following diagram depicts ideal gas behavior now? Right, that means PV is equals to nRT. This equation it has to be followed. So V and T, so V is directly proportional to the temperature, is a straight line. This is correct. So therefore P and V, so P is inversely proportional to V, so it is inversely proportional graph, it should be like this. It should be like this. Clear? This is wrong graph. So P and T, right? So here P volume constant, P is directly proportional to the temperature, therefore volume is constant. So this is correct, So PV is equals to, therefore nRT. Clear? So therefore this is nothing but Y is equals to mx. Clear? So therefore it should be like a straight line. Clear? So therefore it should be the straight line. No, this is not the correct one. Clear? So that two are the correct answers. Clear? Now we will go for another question. right, right. Now this is also one different type of question. No, let us see 1 mole of H2 gas. No, therefore there is a one cylinder, one volume is there, one box volume. This is volume is given 1 meter cube. In this one now H2 gas is there. No, how much now? 1 mole. Clear? So now the temperature was how much now? Temperature was nothing but 300 Kelvin now. Clear? This box was heated to final temperature is how much now? T2 is nothing but 3000 Kelvin. Clear? So now that gas now, this gas will be converted into like a hydrogen atomic gas. So that means hydrogen which is going to break now. Therefore what is going to happen now? What is going to happen now? Therefore number of moles of the gas now, it is going to get double of this. Clear? Clear? So here now when the gas is broke into this one now, therefore here it will become like a 2 moles. Clear? So when it is breaks into this one now. Clear? Now what will be the pressure now? Final pressure. Initial pressure is P. So final pressure is nothing but we want to calculate it. Clear? Now we'll see now how many, right? So here pressure PV is equals to nRT. So therefore here volume is constant, here R is constant. No? P by NT, it will be equal to R by V. This is constant. Clear? So therefore here P1 by N1 into T1 is equals to P2 by N2 into T2. Clear? So therefore initial pressure is P. So number of moles is nothing but 1 into temperature is nothing but 300. It will be equal to P2. So number of moles it will become like a 2 times into, therefore here T2 is nothing but 3000. So therefore this is nothing but a 10 times. Therefore P2 will be equal to 20 times of this pressure. Clear? Right. We'll see one more question now. Right. Here a balloon has 5 moles of helium at 7 degrees centigrade now. Calculate number of atoms in the helium of the balloon and the total internal energy of the system now. Clear? So here helium, therefore helium is what now? Helium is nothing but a monoatomic. Yes, sir? Monoatomic. Therefore here number of moles are how many? 5 moles are there. Here, so you know 1 mole it will be equal to how many number of atoms will be there? Avogadro number of atoms now. Clear? So therefore here like that 5 moles now, therefore 5 moles now, 5 into, therefore Avogadro number of atoms it will be present onto this, right? So what will be the Avogadro number now? Right, Avogadro number is 5 into 6.023 into 10 to the power of 23 atoms. This many atoms it will be present in a 5 moles of our, right? So 5 moles of the gas, that is the balloon contains this many number of atoms now. So you can rewrite it as, therefore here it is 15, 10, 1. So 15, therefore 5, 1, 10, 11 means it is also 1 point, therefore 30 into 10 to the power of 23 atoms. This many number of atoms will be present. Clear? So he is asking what will be the total internal energy? Internal energy is nothing but a F by 2 NKT or nRT, also you can rewrite it as, no problem. So NKT or nRT, so this is NKT means capital N, number of atoms. nRT is nothing but a, so you can rewrite it as moles now. So you can write it as number of moles into RT, also you can write it now. Monoatomic means degrees of freedom is 3 by 2. How many moles are there now? 5 moles now, into R, into temperature is how much now? 7. Therefore 273 plus 7. Plus 7 means 280. Clear? So how much now? 280. So this is nothing but 140. So this is right, 15 into 140 into R. Multiply it, no, you can get your answer. So here 15 into 140 into 8.3. Therefore 17430 joules. This much amount of total energy is present in that one. Clear? Let us see one more question now. Right? Here now let us see. So calculate the number of degrees of freedom of a molecule of hydrogen. Hydrogen molecule. Hydrogen molecule means what? H2, diatomic. Calculate the number of total degrees of freedom. So hydrogen molecule will be having, so therefore 5 degrees of freedom now, right? But all the molecules total degrees of freedom we want to calculate. So in 1 cc of hydrogen at NTP. Therefore here 1 cc. You know that at STP, therefore 1 mole of the gas, 1 mole of gas at STP. So it is going to occupy 22.4 liters of the volume, or we can rewrite it as 22.4 into 10 to the power of 3, 22400 cc. That means 1 mole of the gas, it is going to occupy this much volume now. Therefore in 1 cc, how many moles are there now? In 1 cc, you can rewrite it as 1 by 22400, this many number of moles. You know that in 1 mole, how many atoms are there now? Avogadro number of atoms now. Yes or no? So therefore here in 1 cc, how many number of atoms will be there now? Number of, that is molecules, number of molecules. You can rewrite it as 1 by 22400 into, this is your Avogadro number. So therefore here you can write it as, so 6.023 into 10 to the power of 23 divided by 22400. So this many atoms will be, molecules will be present here now. How much it will be now? Let us see. 6.023 divided by, okay, this 2 zeros, 21, you can rewrite it as divided by 224. So that means 0.0268 into 10 to the power of 21. So you can rewrite it as 21 means 1 you take it now 20. So 0, therefore 19. So 2.68 into 10 to the power of 19 molecules are present. So therefore each molecule is having this many degrees of freedom. Therefore total degrees of freedom, total number of degrees of freedom, it will be equal to 5 into, so 2.68 into 10 to the power of 19. How much now? 5 is a 44, 30, 34, 3, 10, 13, 13 into 10 to the power of 19 degrees of freedom it will be possible. Clear? Right? So this is one different type of model questions now, where it is involved this point. Clear? So like that each and every problem will give some information, you try to learn it from that. Clear? Now an insulated container is there. So there is one container is there now. This is one container. So therefore it is having molar mass now. Suppose n moles are there. So therefore total mass is nothing but nm. So therefore this is going with a speed is v0. Now if the container is suddenly stopped, therefore change in temperature now. Suddenly stopped means what will happen now? Therefore you can rewrite it as initial kinetic energy is how much now? Initial change in kinetic energy. So that it will be the raise in internal energy, right? So this internal energy you can rewrite it as like by constant volume n CV into delta T, or you can anyway you can write it half. Therefore total mass is nothing but nm into v0 square. It will be equal to, therefore n, therefore here you can write it as like a monoatomic monoatomic gas, no? So you can rewrite it as 3 by 2 nRT, nR into delta T. Why monoatomic? 3 by 2 nR into delta T. So therefore here 2 get cancel out, no? N and N get cancel out, no? Delta T can be written as m V naught square. This is by 3R. This is your answer. Clear? So in this way you can solve it, no? Or you can use it this formula here, no? So therefore NCV into delta T also you can use it, so that total heat gain, no, like that also you can calculate it, no? CV you already know it, no, for the monoatomic gas. Clear? Now let us go for one more question. Right students, you will see this question, no? So this question is slightly interesting, and also you will understand the mean free path, no? What is mean by mean free path, and how much time, how much distance they are going to take place, no? So slightly a new type of questions, no? So let us see here, no? What is given? At 10 small planes are there. There is a small planes are there like a gas molecules. So flying at a speed of 150 km per hour in the total darkness. There is no darkness is there, no? There is no light. We are not able to see which molecule is coming now. In this volume it is there, no? So you are in the one plane. We are in the one plane, no? Flying randomly within the space. No one, no way knowing where the other planes are there, no? On an average, how long the time will elapse between near the collision, no, with your plane, no? Assume the rough competition through the safety region, and the plane is approximated to the radius of this one, no? That means like our 10 molecules are there, no, they are going in a random way. So how much time it will take place to get collided? That is like that experiment, no? Clear? So time collided, no, first of all you should know how much distance it is traveled, no? You know mean free path. What is the mean free path, no? So 1 by root 2 into pi into n into d square. Clear? This is your mean free path now. So you know that, right? So here velocity is equals to mean free path by time. So therefore your time is equals to, mean free path by velocity. You can get it, no? The time taken to get collided here, no? Clear? So here what we don't know? We don't know what is the mean free path, no? We know the speed. Yes, sir? So here what is n? N is nothing but a number of molecules per unit volume. N is nothing but what? Number of molecules per unit volume. What is number of molecule? Number of planes are there? How many? 10 planes are there, no? By this one, no? This is 20 into 20 into 1.5 kilometer cube. Okay. So this is in terms of like a kilometers, no? Kilometers means 10 to the power of 3, whole cube means 10 to the power of 9. Clear? So therefore here 10 to the power of 9. So you need to simplify this one, no? This radius or diameter it is given, no? 20 meters, no? So substitute it, no? What you will get it now? 1 by root 2 into pi, therefore 3.14 into number of molecules are nothing but 10. So taken top, no, 20 into 1.5 into 10 to the power of 9 into d square. D square means nothing but 20 square, therefore 20 into 20. This is your mean free path. Clear? So therefore here, therefore this 20 get cancelled out, no? Therefore how much you will get it now? Therefore here, no, this is now 8. So that is nothing but 1.5 into 10 to the power of 8 divided by root 2 into 3.14. Clear? So how many meters it will take now? Therefore 1.5 divided by 1.414 is equals to divided by 3.14. Therefore you will get it as 0.337 into 10 to the power of 8 meters, or you can rewrite it as how much it will be now? You can take it as 3.37 into 10 to the power of 7 meters. This is your this is your distance that can be traveled, no? In kilometers you can write down 3.37 into 10 to the power of I can write down 4 into 3, therefore 4 kilometers. This much distance, on an average distance, this much distance they are going to travel to in order to get collided now. Therefore the time taken now here, how much now? 3.37 into 10 to the power of 4 kilometer divided by speed is how much now? 150 kilometer per hour into hour. Can cancel out, no? So how much time it will take now? Therefore, so here 3, okay, we can write down, therefore 2 zeros, no? 33700 divided by 150. Therefore, nearly 224 hours it will take, no? Therefore, 224 hours it will take to collide it onto this. Clear? So that means, so you can get it as like a rough estimation, no? Therefore, how the time collisions, no? Therefore, the frequency here. This is a time collision, no? In your previous video, collision frequency I discussed, no? Collision frequency is nothing but 1 by time. So therefore, it is nothing but a velocity by mean free path. This is your collision frequency. I already discussed in the previous video, no? Clear? Right? You will get one rough estimation, no? How much time it will take to get collided. Clear? So 224 hours means almost it will take days only to get collided with another one more plane. So now we'll solve this problem, no? Calculate the RMS speed of a nitrogen, right? We have to calculate the RMS speed of a nitrogen at STP. So pressure is given 1 atmospheric pressure, temperature is given 0, density is also given now. So here RMS speed, what is RMS speed now? Formula, we already know it. So here RMS speed, so it will be equal to, therefore 3P by it is rho. Where in terms of density now. So here what you can write it now? Therefore here 3, pressure is given as how much now? 1 atmospheric pressure, 1 into 1.01 into 10 to the power of 5 Pascal divided by density is nothing but a 1.25. How much it will be? So we will simplify this one. So we will estimate it, okay, right. So therefore here 3 into 1.01 divided by 1.25. So nearly root of 2.4 into 10 to the power of 5. So nearly 24, therefore you can write it as 24 into 10 to the power of 4. Nearly 25 you can take it, no? Therefore 25 means nearly 4.9, something like that, no? Into 10 to the power of 2 meters per second. No? This is your RMS speed of a gas molecule of our nitrogen molecule. No? Clear? Right? So now we will go for one more question. No? Let us see. Right. If RMS speed of a nitrogen molecule is 490 meters per second at 273 Kelvin, find the speed of a hydrogen molecule at the same temperature. See, we already studied this one now. RMS speed is equals to, so 3 RT by M. Clear? So this is nothing but at same temperature they are telling, no? So RMS speed, so it is inversely proportional to root of gram molecular weight. Clear? So here RMS speed is inversely proportional to the mass, no? So for your for the hydrogen molecule by nitrogen molecule, so here mass of your nitrogen by mass of your hydrogen. So nitrogen, so 7 14 14 14 28 divided by 2, therefore root, therefore 14, so root 14 will be your ratio of this one, no? Therefore, so velocity of your hydrogen molecule is nothing but root 14 into, therefore 490 meters per second. Clear? So this it will be your answer. Clear? Now we will go for one more question. Now we want to calculate the number of molecules in each cubic meter of a gas at 1 atm and 27 degrees centigrade. Number of molecules. We know that, so PV is equals to NKT. So therefore here N is nothing but a number of molecules, PV by KT. P is how much now? Pressure is given 1 atmospheric pressure, 1.01 into 10 to the power of 5 Pascal. So 1 cubic meter, no? 1 divided by, so 1.38 into 10 to the power of minus 23 Boltzmann constant. temperature is nothing but 300 now. So therefore here you can take it now, therefore here then take it here now, 1.01, right. So this 2 zeros no, you can take it here now, 2 zeros, this point no. So here 2 zeros no, 101 by 138. So therefore here 2 zeros 1 3, therefore it is into 10 the power of 26. Clear? So 101 by 138 means nearly 0.9. So we'll see. So accurate value 101 divided by 138. So 0.73, sorry, 0.73 into 10 the power of 26 or 7.3 into 10 the power of 25 molecules. Clear? So this is also one very important formula. Clear? Now let us go for one more question. So we'll see this question now. Find the RMS speed of a oxygen molecule in a gas at 300 Kelvin now. See what is RMS speed formula? RMS speed, it will be equal to 3RT by M. So what you can write it now? 3 into R value is 8.3, temperature is 300. So by gram molecular weight of the oxygen molecule is nothing but 32 grams, therefore into 10 the power of minus 3. Clear? So therefore if you really solve this one now, therefore nearly you will get it as 483 meters per second. So we will get your answer now. Clear? So in this way you can solve this problem now. Clear? So this is most important formula. Clear? Now we will go for one more question now. Here, right, this is one different model question now. See, here a mixture of hydrogen and oxygen has a volume is given, temperature is given and pressure is also given. Mass of this mixture is given now. Calculate the mass of the hydrogen and oxygen present in the mixture. So if you want to calculate the mass of an hydrogen and oxygen, you have to calculate number of moles of hydrogen and number of moles of oxygen present in that mixture. So first of all, let us calculate how many moles is there now in this one now. Let us see now. So you know simple equation, we can write down PV is equals to number of moles of the mixture into R into T. Clear? So here N of this mixture no, so you can take it as PV by RT. P is how much now? 100 kilopascal. 100 kilo means 10 to the power of 5 pascal into volume. Volume is how much now? 2000 centimeter cube, that means 10 to the power of minus 6 meter cube by therefore 8.3, temperature is about 300. Clear? So how much you will get it now? These 2 zeros, this is minus 5, so this will get cancelled out now. So you will get it as 2 by 3 into 8.3. You will see this value now. How much you will get it now? 2 divided by 3 again divided by 8.3. So therefore I will get it as 0.08. So number of moles of the mixture I got it as, number of moles of the mixture means number of moles of your hydrogen plus number of moles of your oxygen, that is given as 0.08. Clear? Now also he gave this mass no, right? So here how to calculate this mass now? Therefore if you add therefore gram molecular weight of your hydrogen into number of moles plus gram molecular weight of your oxygen into number of moles, it will be equal to mass of this one no, it is nothing but 0.76 grams. Clear? So what will be the gram molecular weight of your hydrogen no? Therefore 2 grams, 2 N1 plus gram molecular weight of your oxygen is 32 into N2 is equals to 0.76. Clear? So we have these two equations no. Therefore from these two equations you can solve N1 and N2 values no. So how to do it now? Just to take it 2 common no. Therefore N1 plus therefore this is 16. So N2 divide by the 2 0. So this for 3 8. Clear? So N1 is nothing but so 0.08 minus N2. So therefore 0.08 minus N2 plus 16 N2 is equals to 0.38. So this you can take it now. Therefore here 15 N2 you can take it as 0.38 minus 0.08. So what you will get it now, if you subtract it now, 15 N2 you will get it as 0.3. So N2 is equals to 0.3 by 15. Clear? So 0.3 by 0.02. That means number of moles of your oxygen is given as 0.02. So substitute in this one no. So N2 value is 0.02 taken here no. So N1 number of moles of your hydrogen is 0.06. But he is asking mass of this one no. So how many mass of this one now? Just multiply with this one no, mass of your hydrogen no. So mass of your hydrogen. So this is for the hydrogen no. N1 into M1. So 0.06 into 2, therefore 0.12 grams. This is your hydrogen. Mass of your oxygen no. So N2 into M2 given as N2 0.02 into, so mass of this one now is 32. Clear? So therefore what you will get it now? So 0.64 grams. If you add these two, 0.64, 0.12 means 0.76 grams. Clear? So in this way you are able to solve the mass of your hydrogen and oxygen in a given mixture. No? Clear? So slightly one new model question. No? So try to concentrate on to this. Clear? Now we will go for one more question. Right? This is a simple question. No? So it is given as RMS speed of your oxygen is given 500 meters per second at room temperature. At the same temperature it is asking now. Therefore, what will be the RMS speed formula now? That is nothing but 3RT by therefore M. It is inversely proportional now. So for your hydrogen by oxygen, it can be written as, so here mass of your oxygen by mass of your hydrogen now. Mass of the oxygen is how much now? Mass of the oxygen, that is 32 grams by hydrogen is 2. So therefore here it is 16, therefore it is 4. So velocity RMS speed of your hydrogen molecule, this is given as 500 into 4. So therefore 2000 meters per second. So B option will be your correct answer. Clear? Now we will go for another question. Right. So there is an electric bulb is there, no? Volume is given. So here volume, what is the volume of the no? Volume is nothing but 250 cc. Clear? Clear? So 250 cc. Cc means what you can write it now? So centimeter cube. So we can write it as 250. So 10 to the power of minus 2. Therefore 10 to the power of minus 6 meter cube. Therefore 25 into 10 to the power of minus 5 meter cube will be your volume. And here given pressure, no? Pressure is nothing but 10 to the power of minus 3 mm of Hg. So mm pressure it is given as rho gh, no? Because 76 centimeters of Hg is 1 atmospheric pressure, no? Here it is given 10 to the power of minus 3. So we can write down rho gh. Density of the mercury. Density of the mercury is nothing but 13,600 into G value is 10. Height is given as 10 to the power of minus 3 and millimeter. So therefore 10 to the power of minus 6 Pascal. So what you can write, these 3 zeros get, no? Therefore 136 into 10 to the power of minus 3 Pascal. This is the pressure, no? So temperature is given. How much now? Temperature is nothing but 27 degrees centigrade. That is nothing but 300 Kelvin. Clear? Avogadro number is given now. We have to calculate number of molecules. You know the number of molecules, how to calculate now? PV is equals to NKT formula. K is nothing but a Boltzmann constant, already you know it, no? So number of molecules, no, we can rewrite it as PV by, therefore KT. P is given as 136 into 10 to the power of minus 3. Volume is given as 25 into 10 to the power of minus 5 divided by 1.38 into 10 to the power of minus 23. Temperature is nothing but 300. Clear? Now, so this we can simplify it, no? This 2 zeros 138, therefore 136 into 25 divided by 138. So therefore into 3. This will take it top, no? Therefore here 10 to the power of this is plus 20 means here minus 3, therefore 20 minus 5 means 10 to the power of 15. Clear? So here approximation, no, you can take it as 136 and 138 nearly equal, no, you can take it as 1. So 3, so how much now? 7, 8, therefore nearly, therefore 3, 8, no, 24. So therefore 8 point, therefore here 1 taken, no, 1 means 10, 8.3 into 10 to the power of 15 molecules. Clear? So in this way you need to approximate it, no, sometimes in the calculations, no. Clear? So this is here again one formula we used. Now we will go for one more question, no? Right. So this is one interesting question, no? An air bubble of radius 2 millimeter is formed at the bottom of 3.3 meter deep deep river. Calculate the radius of the bubble as it comes to the surface. Atmospheric pressure is given, density of the water is given. Clear? So what is this one now? See here, there is a water is given now. Suppose this is one water. Okay. So water is given now. Now here what happens now? Here there is a air bubble is formed now, where at a depth of 3.3 meters. At a depth of 3.3 meters. This is one air bubble of small radius is given. Radius is given as 2 millimeter. Now, therefore, when the bubble is coming upward, what will happen to its bubble? The bubble, right? So here what is happening now? Here atmospheric pressure is there and pressure due to the water is there, no? Therefore, here at this point the bubble was smaller as it is going upward, no? Therefore, the pressure was decreasing. So, therefore, volume is going to increase. So, when it comes to the top, no, the bubble will become like a larger. Clear? So, we need to calculate what will be the radius of this bubble at this topmost point. Clear? So, therefore, assume that throughout this part, no, we are not seeing any change in the temperature. Temperature is same only. So, pressure and volume. Assume that temperature is same throughout this one. Suppose sometimes they will give a temperature of this one is bottom is smaller, at the temperature is larger, at that time also you have to consider temperature now. Let us see. So, here temperature is constant now. So, as it is going upward, no, therefore, temperature is constant. You can use here in this one, no, there is no other air molecules are not added onto this one, no. So, number of moles it will be number of molecules or number of moles, no, it is same. So, you know that PV is equals to nRT, right. So, here mass is not changing, no, this is nRT. So, n is constant, no, therefore, PV by T it is constant. When it is constant here, no, so what you can rewrite it now? So, P1 V1 by T1 is equals to P2 V2 by T2. So, here we are assuming the temperature is constant, no, therefore, this temperature is also gone. So, temperature is same here and here, no. So, pressure into volume 1, so pressure into volume. Now, here at this point, no, we are considering this is 1, this is 2. So, at this point, what is the pressure now? Here there is an atmospheric pressure is there and pressure due to this water. Clear? At this point, therefore, here atmospheric pressure plus pressure due to water, that is nothing but a rho GH into volume of this bubble. It is like a bubble means like a spherical will be there. So, you can write it as 4 by 3 pi r cube. R1 cube. Clear? So now when it is comes to the top now, when it comes to the top, what happened now? This water pressure now was not there. Here only one atmospheric pressure will be there. Here atmospheric pressure into volume of this point now 4 by 3 pi into R2 cube. Clear? 4 by 3 pi, 4 by 3 pi get cancelled out now. Then you can simplify this concept now. Now atmospheric pressure plus rho GH into R1 cube is equals to atmospheric pressure into R2 cube. Clear? So let us see what are given now. In this one now atmospheric pressure is given 10 to the power of 5 Pascal now, density of the water. So here we will calculate. So here 10 to the power of, okay, we will see. This is here 10 to the power of 5 plus density of the water is 1000 into G value is nothing but 10 into H value is nothing but this 3.3 into R1 cube is equals to atmospheric pressure is 10 to the power of 5 into R2 cube. Right. So here 10 to the power of 4, 3.3. Here also 10 to the power of 4 I will take it now. 10 plus, okay, this 10 to the power of 4 taken out now, 3.3 into R1 cube is equals to 10 to the power of 5 into R2 cube. This is 5, this is 1 now. So what you can write it now, this is here 13.3, so R1 cube is equals to, so here 10 into R2 cube. He told that R1 is given at the bottom now, therefore 2 millimeter was here radius. So therefore we can rewrite it as, right, 2 millimeter now, therefore here R2 cube is equals to 13.3 into 2 millimeter cube. We will write down answer also in terms of millimeter cube only. So by, therefore it is 10. Clear? So therefore R2 it will be equal to 13.3 by 10 whole to the power of 1 by 3 into 2 millimeter. So simplify this one now. Therefore 133 divided by 10 into 2 millimeter. Right? Here it is 100 now. So simplify it now, you can get your answer. Clear? So in this way you can solve the problems related to this air bubble now. Clear? Now we will go for one more question now. Right. So here now average translational kinetic energy, very very important no. He told that it is a translational kinetic energy. Translational kinetic energy. What is a translational kinetic energy means? So right, 3 degrees of freedom will be there. So here U is equals to, what you will get it now, 3 by 2, right, of air molecule. So therefore air molecule, right, so it is 1 molecule into 3 by 2 NKT. Clear? So 3 by 2 NKT. Right. So here he gave this value no. So this value it is given as 0.04 electron volt. So we have to convert into kelvins, I mean joules no. So 0.04 into 1.6 into 10 to the power of minus 19 joules no. 3 by 2 1 molecule into K value. K value is given as already 1.38 into 10 to the power of minus 23 into the temperature. Clear? So therefore here temperature you can write it as 0.04 into 1.6 into 10 to the power of minus 19 into 2 divided by 3 into 1.38 into 10 to the power of minus 23. So this many kelvins now. Clear? So try to solve this one now, so you can get your answer. Here So one new way, so energy is used in the, it is given in terms of like a electron volt as a new learning now. Clear? So you try to solve this one no? So that you can get your answer. Clear? Now we will go for one more question now. A gas cylinder is there now, has a walls that can bear the maximum pressure. So here pressure is maximum. So how much now? 10 to the power of 6 Pascal. Clear? This should be compulsory like P2. But here this cylinder no, what will happen now? This cylinder, so here what happens now? Here initially the pressure initial pressure is how much now? 8 into 10 to the power of 5 Pascal. So volume is V. Now the temperature is how much now? Temperature, initial temperature is 300 kelvins now. Now what happens now? So here this should be compulsory final pressure, then it will be able to break now. Therefore temperature we want to calculate it now. Here volume is not changing, there is no neglected change in the volume. So at what temperature the pressure will, this cylinder will be able to break it. So P and T relation now. Therefore here PV is equals to nRT. So here P by T, therefore nR by V. So this it will be equal to constant. Clear? So therefore here P1 by T1 is equals to P2 by T2. Clear? So pressure is how much now? Pressure, initial pressure is nothing but 8 into 10 to the power of 5 by, therefore here it will be 300 now. It will be equal to, this is 10 to the power of 6 by T2. Clear? So here T2, so you can write down 10 to the power of 6 by, therefore 8 into 10 to the power of 5 into 300. Clear? So therefore here you can write it as like a, this is 10 divided by 8 into 300. Clear? So therefore now 10 divided by 8 is equals to into 300. So you will get it as 375 Kelvin. At the temperature of 375 Kelvin, no? Therefore this cylinder is able to break it. Clear? So this is one simple concept, no? Now let us see one more question. Here the density of the ideal gas is given now. Density of the gas is given at STP. Calculate the molecular weight. Okay, so therefore at STP, no. So what is the pressure? No, pressure is equals to okay, PV is equals to nRT. What you can write? No, PV is equals to nRT means mass by gram molecular weight into RT. So taken here, no, gram molecular weight. So this taken, no, mass by volume into RT by P. So mass by volume is nothing but a density. Gram molecular weight you can write it as RT into density by pressure. So R is nothing but 8.3 into temperature. STP means temperature is nothing but 27 degrees or 0 degree centigrade, no. So standard temperature pressure, therefore 273 into density is given how much now? 1.25 into 10 to the power of minus 3. Okay, density we will write down in terms of SI unit, no. 1.25 into 10 to the power of minus 3 gram per centimeter cube. Clear? Therefore here you can write it as 1.25 into 10 to the power of minus 3, 10 to the power of minus 3 divided by 10 to the power of minus 6 kg per meter cube. Therefore this will get cancelled out, no, 1.25. Therefore 1.25 by pressure is nothing but 1 atmospheric pressure, 1.01 into 10 to the power of 5 Pascal. Clear? So try to simplify this one, no? How much it will be now? 8.3 into 1.25 into 273. So is equals to divided by 1.01. So therefore here 279 into 10 to the power of minus 5 kg. Therefore here grams, no, you can take it as 10 to the power of minus 3, so that it will get grams, no. Therefore 2.79 grams. Clear? So this is your ideal one gas no who's having gram molecular weight is this. Clear? Now we'll go for one more question. No? Right. Estimate the number of collisions per second. Collisions per second means what? He is asking indirectly collision frequency onto this. So we already studied in the previous video, no, collision frequency. So we know that velocity is equals to mean free path by time. So therefore number of collisions, okay, suppose if you are taking, no, so number of collisions per unit time is nothing but a frequency. Velocity is equals to wavelength into frequency. So collision frequency is nothing but a mean free path by velocity. Sorry, velocity by mean free path. Here velocity by mean free path. Clear? So here mean free path he gave, no, 1.38 into 10 to the power of minus 5 he gave, but we don't know the velocity. So therefore here velocity it will be given as nothing but a RMS speed. We can rewrite it as, so 3 RT by M. Which one? No, hydrogen. Okay. So 3 RT by therefore M gram molecular weight. 8.3 into temperature. Temperature is how much now? STP. Therefore 273 divided by. So gram molecular weight of this hydrogen molecule is 2. 2 into 10 to the power of minus 3 actually. Clear? So how much will get it now? 3 into 8.3 into 273, so is equals to divided by 2. So therefore you can rewrite it as 3398 into 10 to the power of 3, right? 33980. So if you take it as, okay, 33980, so take it as 184 into 10, therefore 1840 meters per second. This is here the speed of the hydrogen gas molecule now at this point. So it is given as therefore here speed is given now 1840 meters per second now by 1.38 into 10 to the power of minus 5 into centimeter 10 to the power of minus 2. Clear? So therefore you can take it top, no, therefore 1840 divided by 1.38 into 10 to the power of 7, right? Now so 1840 divided by 1.38, so 1333 into 10 to the power of 7, this many collisions per second, right? Yeah. Okay. So we already discussed regarding the KTG theory. 2 videos are there, numericals, no, part 1 and part 2. By these videos, no, therefore you will be very thorough in this kinetic theory of gases, no. So right. So thank you for watching. Please subscribe to my channel now, and also share these videos, no, those who want to learn the physics, right? Thank you.